Okay, welcome to section 7.2. In section 7.1, we solve systems by graphing. In section 7.2, we are going to solve systems using the substitution method and the elimination method. The elimination method can also be called the addition method. When doing the substitution method, there's a procedure that you want to follow. The first thing you want to do is you want to solve one of the equations for one of the variables. It does not matter which variable you solve for. It does not matter which equation you solve for. I like to look for a variable that has a coefficient of 1. So an example would be x plus 2y equals 9. This x would be the easiest one to get alone since it has a coefficient of 1. And you could do that really easy by subtracting the 2y to the other side. So you'd have something like x equals 9 minus 2y. Okay, once you have that variable isolated, you're ready for step 2. In step 2, you're going to substitute the expression that you just found into the other equation for the variable that you solved for. Once you do this, you're going to be able to solve the equation for the variable, and then you'll have to substitute again the value you found in step 3 into the equation you wrote in step 1. So it's a lot easier to explain with an example, so let's look at the next problem. So let's say I asked you to solve x plus y equals 4 and 2x minus y equals negative 1. I personally like to write them next to each other instead of stacked on top of each other. It's just a personal preference, so you can do it, you can choose not to. Okay, so look at your two equations. You have the equation on the left, x plus y equals 4. The equation on the right, 2x minus y equals negative 1. I'm going to decide to work with equation 1 because in equation 1, both coefficients are equal to 1. And I am personally going to decide to get the x alone. So to get the x alone, I am going to subtract y to both sides of the equation. And so I'll have x equals 4 minus y. Now, I'm going to take what I just found. X is supposed to be the same thing as 4 minus y. And I'm going to go to the other equation, and I am going to replace the x with the 4 minus y. And now I have an equation that I can solve. I'm going to distribute my 2. I'm going to combine my like terms. Negative 2y and negative 1y make negative 3y. I'm going to subtract 8. 1 minus 8 is, I dropped my negative. Negative 1 minus 8 is negative 9. And I'm going to divide by my negative 3. So y is 3. Now, I need to take that y value and bring it back over to the problem I was working with before and substitute that in as well. X is 1. And so your solution, you write the x first and the y second, is 1, 3. I want to show you, every once in a while you'll encounter a problem that has infinite solutions or no solutions, so I wanted to give you an example of one. The one we're going to do right now has infinite solutions, and let me show you what that's going to look like. I'm just going to scoot this out of the way. Your two equations that you are working with is y equals negative 2x plus 3. And 2y equals 6 minus 4x. Now notice in this problem that y has already been isolated. So don't recreate the wheel, just use it. Y is supposed to be equal to negative 2x plus 3. So I'm going to go to my other equation and substitute that in. 2 times negative 2x plus 3 is equal to 6 minus 4x. I'm going to distribute my 2, negative 4x plus 6 equals 6 minus 4x. I'm going to try to get my x's together, and notice what happens. Both sets of x's eliminate each other, and you're left with no variables at all. So what you have to do is you have to look at your final line here. What you have is 6 equal to 6. If this is a true statement, which it is, 6 does equal 6, that means you have infinite solutions. So that means if you were to look at the graph, this would be one of those situations where the lines are graphed on top of each other and they intersect each other in infinitely many places. If you would have gotten a false situation like 6 equals 0, then that would have meant that there was no solution and that you were dealing with parallel lines. We'll look at one of those examples later. Okay, another method that you can use to solve is called the addition method. A good indicator that you want to do the addition method is if none of them have a coefficient of 1. If they don't, then I would do the addition or the elimination method. When you do this method, you may have to rearrange the equations. Your goal is to find to have the two equations where the sum will result in only one variable. So example, say you have 2x plus y equals 6 and negative 2x plus y equals 10. If you were to add the two equations together, notice the 2x and the negative 2x are exact opposites, and when you add them together, they eliminate. That's what you're looking for. If you don't have that, you're going to have to do a little work to make that happen. So the steps are, first thing you want to do is you want to rewrite the equations so that the variables are lined up. And so the variables on the left match in both equations. Then you'll have to do your multiply step. Sometimes you'll have to multiply one equation, sometimes you'll have to multiply both equations so that you get two terms that are exact opposites. So that would be like that 2x and that negative 2x, so that they're opposites, so that when you add them together, they eliminate. Once you have that, you add the two equations together, you will solve for the variable, and you will have to substitute into one of the original equations and find the other variable. Let me show you what that looks like. So let's say I asked you to solve 3x minus 4y equals 8 and 2x plus 3y equals 9. Notice that none of the coefficients are equal to 1. So based on that situation, I would use the elimination method here. So when you do that, you're going to line them up by like terms. 3x minus 4y equals 8 and 2x plus 3y equals 9. Now, you cannot just start adding them because none of your terms are opposites. So you can either do some multiplication to try to make the x's opposites. So 3x and 2x could both be turned into a 6x. Or you could try to make the y's opposites. 4y and 3y could both be turned into 12y. It doesn't matter which method you do or which variable you use, but you do need to try to make two of them opposites. Sorry, I didn't mean to erase all of my writing, just the black writing. Okay, I'm actually going to opt in this problem to get my y's to be opposites because they already have opposite signs. So 4 and 3 both go nicely into 12, so I just have to figure out what to multiply by to make them turn into a 12. Okay, so if I take the 4 and multiply by a 3, I will get a 12. Now when you do that, you have to multiply the whole equation. So you have to do 3x times 3, negative 4y times 3, and 8 times 3. And then the bottom equation, in order to make the 3 turn into the 12, you have to multiply by 4. So you have to do 2x times 4, 3y times 4, and 9 times 4. Okay, once you have exact opposites, then you can add the two equations together. So 9x and 8x make 17x. Negative 12 and positive 12 eliminate, and 24 and 36 make 60. Now you can solve for your x by dividing each side by 17, and x would be 60 over 17. Now you still have to find your y. So pick one of your original equations, doesn't matter which one. I'm just going to pick the bottom one. 2x plus 3y equals 9. And where the x is located, I'm going to put in 60 over 17. Now, I'm just going to let my calculator help me with the fractions. 60 over 17 times 2 is going to be 120 over 17. Then I'm going to subtract that from both sides. So I'm going to have 3y equals 9 minus 120 over 17. And again, I'm going to let my calculator do that for me, which is 33 over 17. And then I'm going to divide each side by 3. And I'll let my calculator do that for me as well. And when I divide by 3, I get y equals 11 over 17. Now, for those of you that are not comfortable with fractions, I can show you how to do that if you want. Let me take a little video of my calculator for you. Okay, so if you would like to do this, all you have to do is type it in just like division. So your 60 over 17 is just going to look like 60 divided by 17. Okay, when you look at your screen, it's going to look just like that little fraction with the slash. Now, if you hit enter, you're going to get a decimal, and that's probably not what you want. So to turn it back into a fraction, you have to use the little button that says math. And then if you notice option 1, it says frac. That's what you want. So select option 1, hit enter again, and it'll turn you into a fraction. Now, we had to do 2 times 60 over 17. So once it's in there, you can just hit times 2. And if you have the updated version of the calculator, it'll keep it in there for you. So that's our 120 over 17. Now, we needed to do 9 minus that number. So we're going to do 9 minus 120 over 17. And again, I'm going to hit math, fraction, enter. And then I want to divide by 3. So I'm just going to hit my divide by 3. And that'll give me the 11/17. Okay, now remember, once you have this, you need to write this in ordered pair format. So you need to put the x number first, which is 60 over 17, and the y number second, which is 11 over 17. I want to show you one more just so that you can see what a no solution is going to look like, and then we'll do a story problem together to wrap this up. Okay, so again, I want you to solve this, and I want you to do the addition or the elimination method. Okay, so I'm going to multiply the top equation by a -2 so that I can get opposites. So when I do that, I have to do x times -2, and y times -2, and 3 times -2. The bottom equation does not need to be multiplied because I already have opposites. Okay, once you have opposites, you can add your 2 equations together. So when you do that, -2x and +2x eliminate and make 0. -2y and +2y eliminate and make 0. So it means you have 0 on the left-hand side of your equation. On the right-hand side of your equation, -6 and -4 added together make -10. Now this is a false statement. 10 and 0 are not the same amount, so that means this problem has no solution. So if you were to look at the graphs, the 2 graphs would run parallel to each other and never intersect. So that's why there's no solution. So let's check out one story problem. I think this is the most challenging of the story problems. The mixture problems, in my opinion, are the toughest. Pat Williams, a pharmacist, needs 500 milliliters of a 10% phenobarbital solution. She has only a 5% phenobarbital solution and a 25% phenobarbital solution. How many milliliters of each solution should she mix to obtain the desired solution? Okay, so I'm going to scooch this out of the way. First thing you have to decide is what your variables are. I like to use x and y as my variables. That's just my habit. Okay, so the unknown is how much of each solution she needs. So let's let x be the amount of the 5% solution. And let's let y be the amount of the 25% solution. Now, if you were in a chemistry class, you would need to be more specific than amount. We are measuring in milliliters here. So your answer will be milliliters when you're done. Okay, so the first thing I look for is totals. She needs to make total of 500 milliliters. She needs to make that out of the 5% solution and out of the 25% solution. So your first equation that you could write is that x plus y is 500. So the amount of the 5% and the amount of the 25% together needs to make the total amount, which is the 500. Now you need to worry about the percentages. She needs a 10% solution. Well, the x is a 5% solution. So you need to convert that 5% to a decimal. So 0.05 of the x. The y is a 25% solution. So 0.25 of the y. And she needs 10% of the 500 to be phenobarbital. So 0.10 of the 500. Okay, so if you want to do the elimination method, then you can do this really easy by multiplying. So I'm going to multiply the bottom equation by 100, and that's going to eliminate all my decimals, which might be beneficial to you. And I'm going to multiply the top equation by -5. Okay, the reason why is when I multiply the bottom equation by 100, when I multiply the bottom equation by 100, that's going to give me 5x and 25y equal to, let's see, we can let our calculator do that, 0.1 times 500 times 100 equal to 5,000. So now if I multiply the top by -5, that'll give me a -5x and a -5y, and then 500 times -5 is -2,500. Okay, that's good for you because when you add the two equations together, the 5x and the -5x are going to eliminate. The 25 and the -5 are going to make 20y, and then the 5,000 and the -2,500 are going to make +2,500. So to solve, you would divide each side of the equation by 20, and so 2,500 divided by 20 would be 125. So you need 125 milliliters of the 25% solution. And then keep in mind that you were making 500 milliliters. So remember that was the x plus y equals 500. So you could substitute your 125 in there for your y and solve. And you could use your calculator to subtract. You would need 375 milliliters of the 5% solution. And then you would have the appropriate mixture that you need of your phenobarbital.